So let's look at a concrete example about how to leverage AI for finance learning. Now, traditionally, you might spend hours manually calculating a discounted cash flow or DCF model for a company. In the process, you have to gather historical financial data, you have to project future cash flows year by year, you have to calculate an appropriate discount rate or WACC, right, weighted average cost of capital. Then you determine terminal value, and then you have to manually check your spreadsheet for errors, and then lastly, you have to format your results for presentation. Now, this entire process might take 3 to 4 hours for a single company, and if you make a calculation error, you might need to start over again. With AI though, you can generate the basic structure in seconds. You can say, please create a DCF model for Apple with the 5-year projections, and then the AI will give you a fully functional template with the formula already in place. And then you might only need to provide key assumptions and check the output. But then this efficiency leads to an important choice for you next. The first option is then you use AI as a shortcut, right? You could use that saved time to skip understanding how the DCF model works. You might generate dozens of valuations without truly understanding the underlying principles of time value of money, growth assumptions for the company, or the risk-adjusted discount rates, or the WACC. Now, academically, this approach creates serious problems for you because you will struggle to evaluate whether a model output is reasonable or not. When your AI-generated DCF values Tesla at $1,500 per share, let's say, while the current market price is only around $250, you won't actually know if you have discovered a massive market inefficiency or if your AI has made an error. You also won't understand the relationship between inputs and output. For example, if changing the discount rate from 10% to 11% cuts your evaluation for Tesla in half, you won't actually know if that's a reasonable sensitivity or if there's a problem with your model. You will also be unable to identify when AI has used an inappropriate assumptions or not. For example, if the AI assumes a 20% growth rate for a mature company in a saturated market, you won't actually recognize that as unrealistic. And when professors or your teachers ask you to defend your analysis in class, you might find yourself unable to explain why you choose certain values from terminal growth rates or WACC components or the forecasting periods. Now, on exams where AI isn't available, you will also struggle with questions requiring conceptual understanding rather than just calculation as well. You also risk developing a false sense of confidence and believing you understand concepts that you actually don't, a very dangerous form of academic self-deception. Now, in your career, these gaps will also become even more problematic. During job interviews, when asked a detailed question about your valuation methodology, your superficial understanding will be exposed. Now, many finance interviews specifically probe your understanding of fundamentals rather than just the ability to produce a result. And when working on real investment decisions, you won't be able to explain or defend your model to clients, managers, or investment committees, which is a very important or critical skill in finance career. And if a market conditions actually change rapidly, like during financial crisis or COVID, you won't have the conceptual foundation to adapt your models appropriately and potentially leading to disastrous investment recommendations. And when AI makes subtle errors, like using inappropriate, comparable, or unrealistic growth assumptions, you weren't able to catch them because you don't actually understand the underlying logic. And your career advancement will stall as you get labeled as someone who can just run the numbers but can't really provide strategic insights. Or there's a second option, which is rather than using AI as a replacement, you can use AI as an amplifier or the co-intelligent partner. So alternatively, you could use the time saved to deepen your understanding. For example, you can use the time saved to analyze multiple companies in the same industry to spot patterns and develop an intuition for what reasonable valuation ranges look like across different sectors. And you can also manually work through key components of the model to verify your understanding, and then use AI to scale your analysis. You can run sensitivity analysis by changing key variables like growth rates, margins, and discount rates to develop intuition about what really drives company value and how different inputs actually affect the final valuation. You can compare DCF results with other valuation methods like multiples or dividend discount model to understand when each approach is most appropriate and how they can serve as a cross-checks on each other. You can also investigate how different economic scenarios actually affect your valuations, building an understanding of how macroeconomic factors influence company-specific projections. And academically, this approach offers significant benefits. You will develop the ability to spot errors in your model or AI outputs. If a small change in assumptions produces a dramatic swing in valuation, you will recognize this as a red flag. You will also understand why certain inputs matter more than others. For example, you will grasp why terminal value often represents the majority of a DCF valuation and what that implies for your confidence in the model. You will be able to articulate why specific assumptions are reasonable for particular companies or industries, demonstrating true understanding rather than mechanical application. You will also excel in class discussions, comprehensive exams, and case competitions while deeper understanding is actually required. You will retain knowledge better because you have built mental models that connect concepts rather than memorizing procedures. And in your career, these advantages also compound. You will excel in interviews because you can discuss not only just how to build models, but why certain approaches make sense in specific situations. You will be able to confidently present and defend your analysis to senior management and clients, demonstrating your value beyond what AI can provide. And when financial markets face unprecedented conditions, you will have the fundamental understanding to adapt your approach rather than blindly trusting existing models. And you will advance more quickly because you will be seen as someone who provides genuine insights rather than just some technical support. Now, I hope using this example can illustrate a broad pattern here, right? AI can handle the mechanical aspect of finance, freeing you from focusing on developing judgment, intuition, and critical thinking. But this only works if you use AI to enhance your learning rather than replacing it. The difference between these approaches will become increasingly apparent as AI tools become more widespread in finance education and practice. And students who choose the second path tend to develop stronger analytical skills and conceptual knowledge. A recent research found that people with a lower baseline ability but good calibration, meaning accurate awareness of their own strengths and weaknesses, actually gain the most from AI assistance. And this suggests that being honest about what you don't understand and using AI to fill those gaps actually strategically is more effective than using it as just a crutch.